Let's just simplify this expression. Just like we saw last time, we do see some need for distribution here. So there's parentheses. This means I'm going to distribute or multiply. We know it's multiplication because it's not showing the operation there. I can show it though, like I just did. Just be careful because some students say, well, I'm distributing 4. Nope, you are not distributing 4, you are distributing -4, and there is a difference. So we need to multiply both of those terms by -4. So that is what I will do. So I'm going to show the work here. -4 groups of 3x's would result in -12x's. And then the second distribution, or multiplication, would be -4 groups of 2y's, which would result in -8y's. Remember, that's a negative? So I'm actually showing that as a minus sign right there. And then the rest of this, it can just drop. So the 5x will drop, the plus 8x dropped, and the -7 dropped because there was no distribution with those terms. Now I have an expression with 5 terms, but these 5 terms, I can see that there is 1, 2, 3 terms with x's. So I know I'm going to have an x term here. I'm going to put my x down. But how many x's will I have? Well, it's 5 minus 12 plus 8 x's, which ends up as a total of 1 x's. You can just put that into the calculator, and that will give you 1. Now, I'm showing the 1. You wouldn't necessarily have to, but I'm going to show it. Now, the other 2 terms, we got a -8y and a -7, both of which are not like terms with each other. So the -8y, I'm just going to drop it, -8y. And then even the -7 dropped. So they still are in the expression there. And your expression may be actually in a different order, but as long as the terms have the same signs, you're in good shape. Now, be careful because some students at this point would be like, well, I know I can combine my x's and y's. 1x minus 8y's would be -7y's. That's not true. You cannot do that. So please do not do that thing, because if you do, you are now combining unlike terms, which you should never do. All right, here's our objective for the day. I can use principles of equality to create zeros and ones and solve equations. This may not make a lot of sense right now. You have covered this before, both in 7th and 8th grade, but we're going to review it again today so that when we see bigger equations, we know how to solve them. So most of the stuff that we saw yesterday, we may not see it for a couple more lessons, but it will come back, combining like terms and distribution. Take 30 seconds and copy this down, please. You need to remember that the objective is showing us what we need to have learned by the time the lesson is over. If you have not learned it, either you weren't paying attention or asking questions, so that we know you need help. So make sure if you do have questions that you do ask. So first up, before we understand equations, we need to understand what a solution is. And in fact, the difference between an equation and an expression is simply an equal sign, okay? So last lesson we learned about expressions. Now we are learning about equations, which is really just 2 expressions that are made to be equal to each other. Now when you see an equal sign, sometimes we think that it just has to be a true statement. It doesn't. Sometimes you may see 1 equals 2. Now, this is a statement. Equal signs are still questions, okay? So when you see an equal sign, you still have to ask yourself, is that a true statement? The statement that I've made here, 1 equals 2, is a false statement. And therefore, we would just declare this as false. But I can make it very quickly. I can make this true by simply saying 1 plus 1 equals 2. Now it is true. Okay? So you need to remember that equal signs are still questions. This would still be a question. Does 1 plus 1 equal 2? And the answer is yes, it does. Okay, now in the future, including today, we're going to see that instead of seeing a 1 there, we may see an x right there. From what we just barely saw, though, we should hopefully understand that the value that I need to replace x with to make this true would be 1. Now we usually show it like this, x equals 1. And then we would even box this in saying that is the value of x that would make this a true statement. So, therefore, we would consider that our solution. So a solution to an equation is a value that you replace the letter with, or variable, that will make the equal statement a true statement. So when it says solve for x, or if it says solve, it's really saying, it's really asking, what value of x makes the equation a true statement? And again, in this case, it would be 1. Okay? Okay, one last note about solutions here is you can see right in this equation, if I replace x with 1, it is a true statement. There are an infinite number of values you could replace x with to make it a false statement. So be careful, because there's an infinite possibility of getting this wrong or making it false. We want to make sure that we are making true statements with the numbers that we're replacing the letters with. Now we're going to go over rules on how to solve equations, which is part of our objective. But first, we can look at something like this, and we can say, well, what number would I replace x with here to make this a true statement? And I know if I replace x with 10, then I would get a true statement, because then it would show 10 equals 10, which, last time I checked, is true. Now be careful, there's people out there that would say that 9 equals 10, and that's good enough. It's just that it's a false statement, okay? So right here, we would even write the solution as x equals 10. So if you replace x with 10, then you get a true statement, and so we would say, well, I have my solution. Now this one may be more obvious than it needs to be, but again, I just need you to understand what a solution is. So when we look at an equation like this one, so something plus 2 equals 10. Now again, I'm avoiding the rules right now. And I think some of you could do this in your head. If you can't, don't worry about it. We'll go over the rules. But the value that I would have to replace x with right here would be 8. So we would write the solution, x equals 8. I can even check. So up here, I would say, well, what happens if I replace x with 8? Well, 8 plus 2 does equal 10. We can even put a question mark over there. That would be a true statement. And then I know for sure that if I replace x with 8, here I have a true statement. So x equals 8 is actually the solution to that equation, all right? So it's important to understand, again, that there are an infinite number of values you could have replaced x with to make it false. You could replace it with 10. That would make it false. If you replace it with -5, still false. Even if you replaced it with -10, still false. Or even any decimal values would make that false. The only value that will make that true is x equals 8. Well, what if we see subtraction in the problem? Still, it shouldn't be a problem here, right? So something -4 needs to equal 10. That's something right here. And this may take some thought right now while we don't have the rules, but I know if I replaced x with 14, I will then get a true statement, because 14 minus 4 does actually equal 10. And then I know that x there equals 14. That's my solution. Now again, the questions on the assignment, they may not ask you for the solution. They may say solve for x. It still means the same thing. What is the solution to the equation? You have to find a value that makes it a true statement. So here's another one. In fact, let's zoom in a little bit. So 5x equals 10. 5 times something equals 10. Now, some of you may even be saying, well, there's no multiplication sign there. Multiplication is the only operation which we do not always have to show. Sometimes we have to show it, but not in this case. That means that if you want to see it, you can put the multiplication symbol between the 5 and the x if that makes you feel good about it. But you do not have to. So on this one, we got 5x equals 10. What we really want, though, is to know what value of x will make this a true statement. And I know if I were to take that x and replace it with 2, then I should get a true statement, right? Let's check. 5 times 2 is 10. Yep, 10 equals 10. Boom. It's a true statement. So now I know x equals 2. That's my solution. So I've seen those 3 operations: addition, subtraction, multiplication, now division, right? Something divided by 2, it needs to equal 10. And again, this may take some thought. Something divided by 2, what would that something be? Is 20. So if you were to replace x with 20 here, then we would have 20 divided by 2. 20 divided by 2 is 10. That's on the left side. 10 equals 10. That would be our final equation there, and that is a true statement. So now I know x equals 20. That's my solution. So some of these you may even see. You don't need to show any work. You could just possibly do it in your head like we did these ones. all right? But again, we have rules that will help us to solve these if by chance we can't do it in our head. Now, I still recommend kind of using these all the time, but you don't have to, because sometimes it may be easier for you not to, and that's okay. So right here, no rules. The rules are the objective, and the rule is the principles of equality. So we see we have a principle of equality for addition, subtraction, multiplication, and division, all four basic math operations. What you'll notice here, though, is that I have written this abstractly. So in other words, if you find that something equals something else, you can add the same thing to both sides, and you'd get a true statement. Still be a true statement. You could subtract the same thing from both sides, still a true statement. Or multiply the same thing on both sides, still a true statement. Same with divide the same thing on both sides, still a true statement. So the principles of equality, you've probably heard this said this way. It just says whatever you do to one side of the equal sign, you must do to the other side of the equal sign. But we don't want to do it without purpose. So here's what I mean by that. If I have, let's say that I have, let's see if I can do this better. Let's say that I have x plus 5 equals 15, okay? Now, we've talked about this before. We talked about this last time. Math is, you can do a lot of things to the math. You just have to stay within the rules, okay? So it depends on what you want it to be, okay? So what I'm saying here is that even with the principles of equality, which I usually show like this, I'll talk about that. But if for some reason, let's say you just wanted to subtract 10 from both sides, you could. Now, you see that I've subtracted 10 from both sides here. The question is, why would I do that? I don't know. I just did it randomly to show that you could. In fact, if you wanted to, like I said, you can do whatever you want pretty much here, as long as you do it to both sides, right? So if I wanted to take the left side and multiply it by 8, I could, as long as I multiplied the right side by 8 as well. You can do that. But again, we want to do this with purpose. So here are the purposes, okay? So when you look at either addition or subtraction, so here's addition or subtraction right here. If you see addition and subtraction in the equation, chances are you're going to have to use either addition or subtraction principles of equality in order to make zeros. Now, we talked about this last time as well. You're going to force values to become zeros. You're going to force them on your own. You're going to take control of the numbers. The reason why you're going to do that is because if you don't, the numbers will control you and they will destroy your life like they have so many before. So, you are going to look and you're going to see that you need to make some zeros. Yes, you will have to do that. Also, for multiplication and division, so you see that's the first part of the objective, right? We need to force values to become zeros. The other part of the objective is to force values to be ones. That's what multiplication and division is for. You're going to make ones. Now, again, we want to do this with purpose. There are specific values that we want to force to become ones. They're the coefficients. Yeah, really just the coefficient, but we can say coefficient, okay? So when you see a coefficient, you're likely going to have to force that coefficient to become 1. If it's already 1, then you don't got to worry about it, okay? Also, it happens usually in this order. You will make zeros, and then you will make ones. So in a general order, you're going to do this one first, and then you'll do this one second, generally speaking. Now you'll notice, like I said before, last lesson we learned how to distribute and combine like terms. Today we are not seeing that. If it were required in an equation, you would usually combine like terms and distribute. Of course, distribution would come first. Okay, but for today, if you need to make zeros, you're going to do that first. If you need to make ones, usually that happens second. If you don't have to make zeros, then we'll just make ones. It doesn't matter. Okay, but again, we're going to do this with purpose. And I know whatever I do to one side, I got to do to the other side. This says find the value of x in the equation below. It should say find the solution to this equation, right? So that we know that it's going to make it a true statement. So I'm looking at this. I think I can do it in my head. I'm not going to do it in my head because we got to go through the principles of equality just so you can get used to them, all right? So the principles of equality say if you do something to one side of the equation, you must do it to the other side. And to show that I'm going to do that, I'm going to set it up with this line right here. What this line does is it brings down the equal sign, but it also separates the equation at the equal sign so that I know if I do any work here, then I'm gonna have to do it here as well. If I do something to the right side, I gotta do the left side. If I do something to the left side of that line, I gotta do the other side as well. Now you see, and I've made that line longer. That's because I'm giving myself some space to work, which I do want. Okay, so what else do I want on this one? What I'd really like to do here is to take this x and just drop it, meaning that I don't want anything added or subtracted to the x. That is what we call isolating the variable, which you possibly have heard before, and I will use it quite often. Isolating the variable, I want the x or the variables all by themselves just to start with. I don't want anything added or subtracted to it. And I'm talking about the 8. This 8, it's no good. I got to get rid of it. When I say get rid of it, I mean I'm going to make it a 0. So I'm going to force it to be a 0 by subtracting 8. Now I put that minus 8 there. That means that I put it there. I changed the equation, but in order to not change the value, if I do it to one side, I must do it to the other side as well. So I'll work from left to right. 9 minus 8 is 1. Now, for some of you that need to put that in the calculator, never feel ashamed to put stuff in the calculator. That's what it's there for. It's there to help. It's there to calculate for you. That's why it's called a calculator. We also have 8 minus 8. You'll notice here that I've made a 0 there. That's because it is a 0. In fact, if I wanted to, I could, let's change this just a little bit, just the way it looks, not its actual value. What I have here is 0, and then I would then have 0 plus x. But here's the nice thing about zeros, okay, is that just like we saw on the last slide, you're going to make zeros with addition or subtraction. We're going to make a 0, which I've just done. And what happens with the zeros that I can ignore it. Okay, so I can just make this go away. So zeros, numbers that are zeros are also like people that are zeros. We get to ignore them. So this x right here, I'm gonna move this over and show this as x equals 1. Now that looks pretty good. Like I said, I think some of you guys could do that in your head. But I'm actually going to check this. I can check to make sure that this is the actual solution by going back to the original equation. 9 equals 8 plus x. But right here, I'm showing that I think x is 1. It should be true. So if I take that x in the original equation, replace it with the 1 that I found, I'm going to check for truthfulness. So I put a question mark over the equal sign just to make sure that it will be true. And I can see here 8 plus 1 does actually equal 9. And last time I checked, and it should always be this way, but 9 equals 9 is a true statement. So now I know that I have found the solution. I can box this in and call it my solution. Because when I replaced the x with 1, it made a true statement. Now I showed that by hand, but since we have calculators, I will no longer show this by hand, the checking. I will use a calculator. I would just type in 8 plus 1, see if it's true. If it is, I'm in good shape. If it's false, then I got to go back and see where I made a mistake. If there's fractions, chances are we made the mistake while typing it into the calculator. If it was something like this, chances are we made a mistake in the principles of equality. We'll have to see. Right here, let's find the value of this x that will make this equation a true statement. So on the last one, we had to subtract from both sides. This one, I can see right away that I'm going to have to add to both sides. How do I know? Well, unfortunately, I'm a math nerd, so I've done a lot of math. But I can see right here, I've got x minus 2.4. What I really want is to be able to just drop that x and get x equals something. This also means that remember, this term is a negative 2.4. I need to zero that out, so that is what I will do. So I'm going to zero that negative 2.4 out by making it a 0, and I'm going to make it a 0 by simply adding it to itself. Okay. So remember, our objective, first part of that objective, let's make zeros. Okay, I did make that a 0, but notice I haven't shown it on the other side, so I need to do that as well. If you do it to one side, you must do it to the other side as well. And what is negative 2.4 plus 2.4? It's 0. Now again, please don't mistake that for me circling that part. It's not a circle, it's a 0. There is a difference. Now in my calculator, I'm going to put 18.15 plus 2.4, and I will find that I get 20.55. Okay, now is this a solution? Well, I can check just to be sure. If I replace this x with 20.55, then I can see what I get. So there's my question mark. And in my calculator, I type in 20.55 minus 2.4. When I push, let's say before I push enter. Before I push enter, I'm expecting to see 18.15, and I do. Therefore, I know that x If I replace that x with 20.55, I get a true statement, which makes it the solution. Okay, so I think those last few, maybe you could have done those ones in your head, but once we start seeing decimals, sometimes it becomes a little bit more difficult. So principles of equality are used. Whatever you do to one side, you must do to the other side of the equal sign. This one is a little weird because it has a fraction. And yes, fractions have destroyed many, many lives before. Please do not let it destroy you, because we can get rid of that fraction. But let's think, okay? So let's go back and think. What is it that we really want here? What I really want is to get 1x equaling something. Okay, so those last two examples that we just did, we forced zeros to happen. You can see now that I'm showing this, that I'm going to force that to be a 1. Now I could, if I wanted to, I could make it a phantom 1, which is what we were showing on the last couple problems. But for this one, I'm gonna keep it as a 1, not a phantom 1, so we can actually see it. Right now I got x divided by 7. Well, I don't want x divided by 7. I want a 1x. So how do I change divided by 7 into 1? What I'm going to do is I'm going to multiply this by 7. Okay. Now, in doing so, some students are like, well, how is that going to give us 1? It's from fraction multiplication. If I make that 7, I'm really multiplying it by 7 over 1. Now you can say, you can see just the way that I have it now, it has changed the equation because I haven't done it to the right side, so I need to remember to do that as well. Multiply by 7. I'm going to skip the fraction multiplication lecture. If you want to learn more about that, just go to YouTube, okay? But right here, what I have is 7 divided by 7, which is going to make that a 1. Now you see I've crossed those out with a 1. It's just slanted. That's okay. Right here I've shown it as a regular 1. That's okay too. 5 times 7 is 35, and this should give us a true statement, right? If I replace the x in the original equation with 35, it should give me a true statement. Let's do so. I'm going to replace that x with 35. In my calculator, I type in 35 divided by 7. I push enter, I get 5. That is a true statement. Therefore, if I replace x with 35 in that original equation, I get a true statement. So I know x equals 35 is the actual solution. By hand, I'm showing 1x equals 35. You do not have to show the 1 if you do not want to. I'm going to keep it there, but if you want to make that a phantom 1, feel free to do so if you're doing it by hand. On the assignment, you're just going to type in 35 into a box, and you'd be done. So here we have a decimal value, and we're still solving for x. We still want to find a value of x that's going to make that true. But what do we really want out of this equation right here? It's the same thing we wanted on pretty much the last two, I think there, is I want 1x. I do not want 0.6 x's. So we've come to the point where I know I wouldn't just multiply 0.6 by itself like we did with the divide by 7 last time. Plus this is a different operation, so we should kind of expect something different. How do you make a value become a 1? As it turns out, anything divided by itself is 1. So I'm going to take that 0.6 and simply divide it by itself. But you can see this is a principle of equality because I put that in myself, which means that if I do it to one side, I must also do it to the other side. Now you could type this in the calculator, 0.6 divided by 0.6. It is 1, so I've already got my 1 there. 4.2 divided, I forgot the decimal. 4.2 divided by 0.6 is 7. Okay, so right now I'm pretty sure if I replace x with 7, I get a true statement. But let's check. If I replace that with 7, what happens to the equation? 0.6 times 7 is 4.2 on my calculator. That makes that equation a true statement. Therefore, I know when I replaced x with 7, I have a true statement, and so I know that x equals 7 is the solution. The main thing on this one, at least from what I understand, is just to make sure you can do this with decimals, and you can. Again, I'm not asking you to actually do the calculation with the decimal. I would rather you put it in the calculator for that. Okay, so fractions like this, all right? Now, fractions on the calculator, these calculators are going to be a little bit different than I think what you saw in 7th and 8th grade, but I'm going to show you how to do it. So on this one, though, let's solve it. Okay, so I'm going to use the principle of equality. What I would like here is for 1m to equal something. I don't really care what it is as long as it makes it a true statement, right? So how do I make, because right now the coefficient of m, the number being multiplied by m, is negative 6.5. I want to force that coefficient to be a 1, just like we saw in the principles of equality slide. So how do you make a fraction of 1? Same thing we did with the decimal. I'm just going to take it, negative 6.5, and I'm going to divide it by negative, not 6.5. I'm dividing by negative 6/5. Because anything divided by itself is 1. We've already put that down. But if I do it to one side, I do need to do it to the other side, negative 6/5. Now right here, I've got 9 divided by negative 6/5. If you do not use parentheses with your fractions on these calculators, you may get incorrect answers. So I'm recommending right now, use parentheses around that fraction. You can see the parentheses buttons just above 8 and 9 on these calculators. Use them, especially when you see fractions. So how do you type this into the calculator? Well, here's how you're going to do it, okay? We want to type in 9. Of course, that's just 9. And I'm going to divide. Now, when you push the divide button, it's going to show a slash on the calculator. No problem. Now, since I'm putting in a fraction, I'm going to use the parentheses. Now, I'm going to show that it's negative. The negative button looks like this. It's at the bottom, right next to the enter button in the bottom right. So you're going to push the negative button so that you know the fraction is negative. There is a difference between the negative button and the minus button. So you do not use the minus button, okay? Now I've got to type in 6/5, right? So there's my 6. Now the fraction button actually is also the divide button because that gives you the fraction line. It's just slanted, that's all. So push the divide button and it will give you the fraction line, 6/5. So push the 5, close the parentheses, and then push the enter button, which I'm just showing as an equal sign. And then you will see what the heck is this? It's a negative 7.5. Okay, now some of you guys may not like fractions, and that's okay. Or you may not like the decimals, I should say. If you don't like the decimal, that's fine. This will do on the assignment, all right? But I'm going to go over how to change this into a fraction as well. Here's what you're going to do. Not that you need it, but you could. So we're gonna go through this button sequence, okay? You got the negative 7.5 on your calculator. You could even push negative 7.5 enter, and then you at the top left. No, not the top left. At the top left, you're gonna go down 2 buttons. You're gonna find this button. It says math. You're gonna push math, and then you're gonna push the enter button. Not just once, but twice. It's math, enter, enter. This will change any decimal into a fraction for you. So I just push math, enter, enter. And you can see now that it's telling me that if you replace the m with negative 15.5, you'd still get a true statement. And we can check, right? So right here, I'm just going to use the decimal though, negative 7.5. So I type in negative 6/5 times negative 7.5. When I push enter, I do see a positive 9. That makes these both solutions. Now you may say, well, how do you have 2 solutions here? It's the same solution, you guys. It's just written different ways. One's the decimal form and one is the fraction form. It doesn't matter which one you use. From what I remember, it doesn't matter which one you type into the assignment either. It's going to give you credit for that. So it's not 2 different answers. It's just one answer written in 2 different ways. This one, same idea, solving for m in this case. I guess we'll simplify the answer if we need to, but we shouldn't need to. Principle of equality, right? Right here I can see what I really want out of this is 1m, not negative 3m's. So once again, how do you make a negative 3 1? Simply divide it by itself. So remember, we're trying to make a 1. We'll make 1s with multiplication or division, principles of equality. It's just if I do it to one side, just make sure you do it the other side as well. So in my calculator, I go and I type in negative 25.2 divided by negative 3. I push enter. My calculator tells me that is 8.4. Now, like we saw on the last slide, you can make this a fraction. I'm not going to because we don't need to. But I will check. So I'm going to replace the m with 8.4. I will see if this gives me a true statement. When I type in negative 3 times 8.4 on my calculator, I do get a true statement, which we know means that if you replace m with 8.4 here, it makes the equation true. That means it is the solution. This one says solve for a. Again, it's asking what value of a will make this a true statement. Well, I don't know. Let's find out. Be careful, though. Because some students may even just put 35 just unwittingly, but that will give you a false statement actually. So be careful on that. This one, the last several that we've done have required only one principle of equality. This one's going to require two. Now be careful because we're going to drop the a term here, but it's not just an a that we're dropping. Remember that each of the terms takes the operation to its left. So we're actually dropping this as negative a. So I want this to be negative a equals something, meaning the negative 7 here, it has to go. I need to make it go away. I need it to be something that I can ignore, like 0. And again, why is this 0? Because it's not being multiplied or divided. So I'm going to make it a 0 by adding 7. That's the easiest way I know how to make negative 7 0. So if I do it to one side, though, I got to do it the other side. Okay, so 28 plus 7 would be 35. And negative 7 plus 7 is 0. Now I said the answer is not 35. It's not. This is not complete because in the end, at the very end of this, what we really need is a equals something, not negative a. In fact, from what we learned last time, there is a coefficient with this negative a, and it is a phantom 1. So it's really 35 equals negative 1a. What I need to do right here is to take that negative 1 and make it a 1. Positive 1, negative to positive. How do you make a negative 1 a positive 1? Same way we've been doing with all the other values, simply divide it by itself. Negative 1 divided by negative 1 is 1, which we've shown here, but negative 35 divided by negative 1, you can put that in the calculator, you will get negative 35. So let's check. Let's see what happens if I take that a and replace it with negative 35. Will I, in fact, get a true statement? In my calculator, I type in negative 7 minus negative, remember you're using different buttons there, negative 7 minus negative 35, and I do get 28. That makes it a true statement. So I know now that I can box this in because it is my solution. It makes the equation true if I replace the a with negative 35. Here we have some decimals, no problem. This calculator will do all that for us. Now, for this though, I'm going to use principle of equality here first. But we're going to take the whole term with us, meaning I'm going to take this negative x over 1.9, and that's the value that I'm trying to drop here. If I can just drop it by itself, I'm going to be in good shape, meaning that this 4.1, I don't want it. And so I'm going to get rid of it by making it a 0. I'm going to subtract it from itself. So 4.1 minus 4.1 is 0. But I know if I do it to one side, I must do it to the other side as well. So 4.8 minus 4.1 is 0.7. Some students don't show the 0 there. Just be careful if you do, because sometimes students won't show the 0, and then they'll do a decimal that looks kind of like this. And I can't tell if this is like a mark on a paper or if it actually is a decimal. So I recommend putting the zeros there, but you don't have to necessarily. So going back a few problems, we saw an x divided by something. This one is just negative though. And so we're going to apply the same principle, but we have to keep that negative in mind. So I need to remember, I need to multiply here to make this a 1x. But again, the question is, what am I going to multiply? Now when I say positive, I'm talking about the coefficient of x. I need to make it a positive one, not negative. I don't want this negative here. So I'm going to multiply this by not just 1.9, but negative 1.9. And if I do that to one side, I must do it to the other side as well. So that becomes a phantom, well, it becomes a 1. And then on the right side, on my calculator, I've got to do 0.7 times negative 1.9, and I get negative 1.33. Okay, well, is that the solution? Because this should be complete now that the coefficient of x is 1 and there's nothing added or subtracted to it. Will that work? Let's go back up to the top and replace the x with negative 1.33. Now, like I said, I'm putting in a fraction to my calculator, so I'm going to actually use parentheses around the whole thing. I'm typing 4.1 minus parentheses negative 1.33 over, so that's the divide button, 1.9, close parentheses. Now again, before I push enter, I'm expecting to see 4.8. I push enter, I see 4.8. I feel good about myself. I box this in and call it the solution because it made the original equation true. But you have to check in the original equation. All right, so in fact, probably should have done this. I put the question mark over the equal sign just to make sure that I'm checking to see if it's true. So this one's going to follow kind of the same idea. We've seen problems like this already, but I know this line's going to drop the equal sign. I really would like to drop this 7/12 x, and it is positive because of the plus sign, which means that 23 has to go. And by it has to go, it means I'm going to change it into a 0 simply by subtracting itself. 23 minus 23 will be 0. 44 minus 23, though, looks like we get 21. And then, yeah, 23 minus 23 is 0. So I zeroed that out. I dropped my 7/12 x already, so that's good. And now I'm ready to make my coefficient of x a 1. I can make this a 1x right now. And I can do that by taking my 7/12 and simply dividing it by itself. We can do fraction division because the calculator is going to do that work for us. On the left side, though, I got 21 divided by 7/12. Remember, you got to do it to the left side, because whatever you do to one side, you got to do the other side. When I put this in the calculator, though, I'm going to put my 7/12 in parentheses just to make sure that the calculator does it correct. So 21 divided by 7/12 gives me, on my calculator, 36. But if I replace x up here with 36, will that, in fact, make the equation true? So in my calculator, I type in 23 plus parentheses, because I got my fraction, 7/12. Remember, the fraction button is just the divide button. Close parentheses, times 36. And then when I push enter, I'm expecting 44. Boom, I see it. So now I know that 36, if I replace x with 36, it makes the equation true. Therefore, I know that x equals 36 is actually the solution. All right, so you've seen in several problems today that you're going to force values to become zeros and ones. Sometimes we use both in a specific equation if we got to use two. If you're only using one principle of equality, it's called a one-step equation. If you're using two, it's called a two-step equation. I just said that and realized you probably don't care. Either way, that's what they're called. You may see that the assignment's called that, okay? There's our objective. Hope you feel pretty good about it.